Now we shall see about transfer function. Transfer function of an LTI system. Transfer function of an LTI system. So let us consider an LTI system, which we already know that. Let us consider an LTI system, whose impulse response is given as h of t, and the input signal, let us consider the input signal is x of t and the output signal is y of t. Okay, and you already know that. So the output y of t is nothing but convolution of the input and the impulse response. So we can also taking Laplace transform on both sides. Taking Laplace transform on both sides, we can get y of s is equals to x of s multiplied with the h of s. So this is one way, and we can also get the another answer by taking Fourier transform on both sides to the same equation. Let us consider the same equation, taking Fourier transform on both sides. Y of omega is equals to x of omega multiplied with the h of omega. So from this we can say that h of s is equals to y of s by x of s, or h of omega is equals to y of omega by x of omega, y of omega by x of omega. So, and this h of s and h of omega is called transfer function. Transfer function. This is called transfer function. So now the transfer function is now defined as the ratio of the Fourier transform of the output signal to the Fourier transform of the input signal when the initial conditions are 0, or we can also say that it is a ratio of the output to the input in frequency domain when the initial conditions are neglected. Okay, so that is all about the transfer function of an LTI system. Either we can get the transfer function in the Laplace domain or the S domain, or we can also have the h of omega, that is in the frequency domain. Okay.